Next, the refining process. Today we are going to see as zone refining process. There's a word itself giving you meaning, zone refining process. This process is based on the principles of fractional crystallization. We know that the crystallization means, suppose if any salt, if you are taking along with the water, that is a salt solution, if we heated the salt, then after that on cooling, then filter, then after filtering we saw that a pure form of crystal is present. For example, sodium chloride we have taken. So here this method is based on the principles of a fractional crystallization. So this word is very important, fractional crystallization. This is a method for refining substance. Refined substance means refining the metal based on their differences in solubility. See, distillation means difference in their boiling point. Liquefaction means differences in their melting point. But zone refining process means is based on the differences in their solubility. For example, if you take a metal which we going to purify or refining this metal, suppose a few percentage of impurities is along with this metal means, if you are heating this metal, so the metal along with the impurity starts to melt and changes into a molten form. Now the impure metal always prefer to seen in the molten region only. So the pure metal now melts and changes into the solid portion. So a zone will be created in the solid portion, a pure metal will be present, and in the molten region the impurities will be preferred in that region. So the impurities are more soluble in the molten state than in the solid state. So this process is carried out in an inert gas atmosphere to prevent the oxidation of the metal. Suppose inert gas means we have to maintain that whole apparatus, which is the whole apparatus which is filled with the inert gas. Inert gas such as helium, neon, mostly neon is used, argon, krypton, etc. So this process is carried out in an inert gas atmosphere because if the pure metal, if some oxygen or nitrogen gas is present in that chamber means it changes into the corresponding metal oxides. So in order to prevent that oxidation of the metal, we are carried out this process in the inert gas chamber. Next, which are the metals we are going to refining using zone refining means only the semi-metals. Semi-metals means we call it as a metalloid. That is a germanium, silicon and gallium. Germanium Ge, silicon Si, gallium Ga. These elements, these semi-metals which are used as a semiconductor, they are refined using this process. Now I will show the diagram or picture to explain the zone refining process. This is a zone refining chamber. This diagram is not given in your textbook, just I show this one for the understanding purpose. See, we have to take a quartz tube, that is made up of sand. So quartz tube we have to take. So here it will be connected to the cathode and anode, etc. Then this chamber which will be filled with the inert gas. We are going to refine silicon, that is a pure silicon metal, and some impurities also present in this. So first we have to take this mixture, that is metal, that is silicon, and impurities we have to take in the right side. Now this is the induction coil, that is which is connector, which is a circular induction coil, or we can call it as a circular mobile, that is mobile induction coil, which will be connected to the electric current. Now if you passing the electric current, this rod or this coil, heating coil will move from here, from the right towards the left side. So while heating, that means while moving this induction coil, the silicon as well as the impurities now starts to melt. So when the coil moving towards this right side, is here this side means now the silicon alone, because it changes into a pure form, pure silicon alone present in this side, and it starts to changes into the solid state. After when this coil moves from here, moving this corner means all the impurities are moving this side, and only the pure silicon will be present in this side. So now by repeating this process, pure silicon will be present in as a solid state, and the impure metal are present here, which will be in the melted form, its molten form. Now we explain. See, one end of the rod is heated using a mobile induction heater, which results in the melting of the metal on that portion of the rod. When the heater is slowly moved to the other end, that means when the heater is moving slowly to the other end, the pure metal crystallizes. That means the pure metal, which one? That is the silicon, which will be crystallized, while the impurities will move on the adjacent molten zone. So immediately the impure metal moves to the near adjacent zone. The process is repeated several times by moving the heater in the same direction again and again to achieve the desired purity level. This process is carried out. We have to take them as an inert gas atmosphere to prevent the oxidation of metals. So finally, germanium, silicon, gallium, which are all semi-metals, and they are used as a semiconductor. So these semi-metals can be refined using this process. After the zone refining, the next method for refining the zirconium and titanium is the method we call it as a Van Argel method for refining zirconium and titanium. For the semi-metals, we are using the zone refining process. But for zirconium and titanium, Van Argel method is used for refining. For example, if you take titanium as a solid state which contains impurities, it's not a 100% pure metal. So this one having some few percentage of impurity, which we going to refine to change them into a pure solid metal. Now that titanium metal along with the impurity is treated with the iodine. So passing through the iodine, that is a solid state which is iodine, both combine together and heat them. It is undergoing a thermal decomposition process. So at 550 Kelvin, it forms a titanium tetraiodide. It is a highly volatile in nature. That means when two solids, when the heating at this temperature, changes into a titanium iodide vapor state. So this will be collected in this chamber. So this titanium tetraiodide, we have to take them in a heating at 1800 Kelvin. The presence of tungsten filament. Here we have to use tungsten filament for the passing of this temperature. Now this titanium tetraiodide decomposed to give titanium as a pure solid and iodine as a solid state, which will be coming as a solid form. So now we get a 100% pure titanium metal. So the same way we are using for zirconium also. So just Van Argel method is otherwise called as a thermal decomposition method. So first equation, the temperature is 550 Kelvin, and after the formation of titanium tetraiodide, which will decompose to give titanium and iodine, the temperature is 1800 Kelvin. So this question which will ask for the 2 mark. So explain Van Argel method for refining zirconium and titanium. Now we are going to see the last refining process is a vapor phase method called as a Mons process. So Mons process means it is mainly for the refining of nickel. So in this process, if you are taking the impure metal, that is nickel along with some impurities plus any reagent, that is here the example is carbon monoxide, CO is a reagent. First it forms a volatile compound, that is a gaseous state, nickel tetracarbonate. This is a volatile compound. That volatile compound then further heating at a 460 Kelvin, it changes into a pure metal, and the same reagent will comes after that formation of the pure metal, that is CO. See, Mons process, this is for refining of the nickel. Then Van Argel, we saw the last class, Van Argel method, that is for refining of zirconium and titanium. Both the Mons process and Van Argel method, they are coming under the vapor phase method. So Van Argel for zirconium and titanium, Mons process for, that is refining for nickel. So first nickel along with some solid impurities combined with the reagents such as carbon monoxide changes into nickel tetracarbonate, which is a highly volatile in nature. That's why here gaseous state. Now at a 350 Kelvin, the same nickel tetracarbonate, that is a highly volatile substance, which on heating at 460 Kelvin, it undergo thermal decomposition, that is a nickel solid and carbon monoxide. So this formation of a solid nickel is a 100% pure nickel metal. Now I am going to explain the application of metals for aluminium, zinc, gold, copper, etc. The first application for aluminium is, we know the most abundant metal and it is a good conductor of electricity and heat. It also resists corrosion. The following are some of its application. The question may ask like, why aluminium is a good conductor of electricity, or why aluminium is resist corrosion? Give reason. Some like the question will become. So the first point for this questions, many heat exchangers or zinc in our day-to-day life, then cooking vessels which are all made up of aluminium. Then it is used as a wrap. Wrap means this covering particle or any packaging material we can use, like a sweet box, in that sweet layer, or in Horlicks bottle the lid which is enclosed with the wrap. So it is used as a wrap, that is aluminium foil, and is used in packing materials for food items. Third point, aluminium is not very strong, so it alloys with, so suppose aluminium alone is used means definitely it will easily breakable. So it's alloys with, that means it is mixed with copper, manganese, magnesium and silicon. So they are all lightweight and they are very strong. So all these metals, copper, manganese, magnesium and aluminium, they combined and they designed for aeroplanes and other forms of transport. So that mixture we call it as a duralumin. We know, already studied in 10th standard, duralumin is used in the aircraft industries. So the next point is, as aluminium shows high resistance to corrosion, so it does not get corroded. Therefore, the aeroplane particles, that is outer layer, fully covered with aluminium. It is used in the design of chemical reactors, medical equipments, refrigeration and units and gas pipelines. It is a good electrical conductor and cheap, and hence used in electrical overhead electric cables and with a steel core for strength. So in general, we can say that used as a cooking vessels, then as a packing material, then lightweight, so it is designing for aeroplanes, then high resistance to corrosion, then as a good electrical conductor. So these are the applications for the aluminium metal. Next we are going to see about the applications of zinc. Zinc mainly is used for galvanization. So in order to prevent the corrosion of any metals like copper and iron, so we have to, the help of electricity, we have to give the coating with zinc. That process we call it as a galvanization. So metallic zinc is used in galvanizing metals such as iron and steel structures to protect them from rusting and corrosion. So any iron and steel industries, to avoid from rusting and corrosion, we are giving a coating of zinc. That process we call it as a galvanization. Then second, zinc is also used to produce die castings in the automobile, electrical and hardware industries. That means automobiles, the outer layer which will be covered with the zinc, that process we call as a die castings. Next, zinc oxide is used in the manufacture of many products such as paints, rubber, cosmetics, etc. So zinc oxide, that is zinc powder, which is used for making paints, rubber and cosmetics. So cosmetics in the sense that is zinc carbonate we are using, that is a zinc carbonate ZnCO3, which is called as a calamine, that main product in the lactocalamine, that is skin, to avoid the skin disease. So zinc oxide and zinc carbonate may be used. Next point, the zinc oxide also used for the pharmaceuticals, plastics, inks, preparation for batteries, textiles and electrical equipments. Zinc sulfide is used, main important one mark question. Zinc sulfide, formula ZnS, is used in making luminous paints, fluorescent lights and X-ray screens. Next, brass of an alloy of zinc, that is zinc, nothing, it is brass means it is an alloy, a mixture of zinc and copper. It is used in water valve and communication equipment as its high resistance to corrosion. So next, applications for iron. Iron is one of the most useful metals and its alloys are used everywhere, including bridge, electricity pylon. Pylon means electricity, electrical instruments, bicycle chains, cutting tools and rifle barrels. Cast iron, which is nothing but is the impure one, is used to make pipes, valves and pump stoves, etc. The magnets which can be made from iron, that is magnetite ore, they are all, and its alloys are and compounds. That means magnets which is prepared from the iron and its alloys. An important alloy of iron is stainless steel. Stainless steel means the percentage of carbon is very very less, and it's a pure quantity or pure quality of iron. It's very resistant to corrosion. It is used in architecture, bearings, cutlery, surgical instruments like scissors, blades, etc. and jewelry. Nickel steel is used for making cables, automobiles and aeroplane parts. Chrome steels are used for manufacture of cutting tools and crushing. That's crushing. This is spelling mistake is there. So crushing machines. See, in all these points, not only pure iron is not used, because pure iron if you use means it undergo easily the corrosion. So to avoid the corrosion, it will along with some other metals. As an alloy form only it will be used. See here magnet, it is an alloy. Here stainless steel, it is an alloy. Then here nickel steel. So that is iron, carbon plus nickel. Here chrome steel means iron, chromium, etc. So full that is iron. They can combine with metals like nickel, chromium, etc. They form the alloys and their applications we saw here. Next application is for copper. So copper is the first metal used by the human and extended as use of its alloy bronze. Bronze is nothing but copper and tin. Brass means copper and zinc. So bronze resulted in the new era, that is Bronze Age. So before knowing the importance of copper, the early man used the first metal is copper only. Copper is used for making coin and ornaments along with gold and other metals. This is alloy with the copper when alloying with gold using as an ornaments. Next, copper and its alloys are used for making wire, water pipes and other electrical parts. So only few points for the applications of copper, and iron and aluminium, zinc is having a 3 or 4 points maximum. Then last only one application is there, that is application of gold. Now the applications of gold. Gold is one of the expensive, that is costly and the precious metals. It is used for making coins and has been used as a standard for monetary system in some countries. This monetary system means that is fund problem. So gold wealth, depending upon the wealth of the gold, the country's development can be predicted. So it is a standard for monetary system in some countries. It is used extensively in jewelry and its alloy form with the copper. So pure gold is not used in jewelry. It is always alloys with the copper, then only making for jewelry. It is also used in electroplating to cover the metals with a thin layer of gold, which is used in watches, artificial limb joints, cheap jewelry, dental fillings and electrical connectors. The last point, gold nanoparticles, that is very minute in milligrams are used for increasing the efficiency of solar cells and also using as a, in some industries they are using as a catalyst also. So okay children, so far we saw about what are metals, what are ores, what are the how you concentrate the metals, then a various extraction process including roasting, calcination, etc. Then refining process, all the types of refining, zone refining, vapor phase method, etc. Thermal decomposition also, and some important applications of various metals like aluminium, copper, iron, gold, so far. So in this chapter we saw everything about the metals and their properties. So one chapter over in inorganic portion. So the next video I will take the physical chemistry first lesson, that is solid state. Thank you children.